Alright, here is Trig Unit Test Review number 3, worksheet number 3. Okay, first one will be related rates problem. Suppose a bird is flying horizontally 40 feet above your head, moving away from you at 20 feet per second. How fast is the angle of elevation changing when your horizontal distance from the bird is 30 feet? So here's the person, the bird is flying away. The y value is staying constant at 40. We know x is changing, we know theta is changing. Okay, but at this moment in time, x is 30 feet, y is 40 feet, so at this moment in time, we can also use the Pythagorean theorem to find z, which is 50 feet. Okay. Alright, dx dt is the speed of the bird, which is 20 feet per second, moving away from the observer, so we know x will be increasing over time, so that is correct to leave that as a positive. Okay, so now we are looking at, we want to find the trig function that will relate theta, x, and 40, and I'm going to use tangent, so tangent of theta is equal to 40 over x. Get this, bring the x up, so I can be able to use power rule there. So tangent of theta becomes secant squared theta, okay, d theta dt, right? Every variable we're finding derivative with respect to time. So 40x to negative 1, go through power rule, bring down the negative 1, subtract 1 from the exponent, and then x becomes dx dt. Okay, one step at a time, we're going to try to move everything over to the other side, isolating d theta dt. So negative 40 over x squared, divide both sides by secant squared theta, and secant squared theta, I can pull this up to the top, make it cosine squared theta. So negative 40 over x squared times cosine squared theta times dx dt. Okay, we know x is 30, so that will be 30 squared. We don't know theta, but we do know cosine of theta based off of the lengths of the triangle. Right? Cosine of theta is simply going to be adjacent over hypotenuse. So adjacent is 30, hypotenuse is 50. So 30 over 50, 3/5. So cosine squared, so 3/5 squared times 20. And then we put all the values in the numerator, put all the values in the denominator, start canceling out, and all that's going to reduce to negative 8 over 25 radians per second. Okay, number 2, find the derivative for our equation xe to the sine of 2y plus 4x equals natural log of y. So this will involve product rule. We have x times e to the u, so this product rule. There's also going to be chain rule involved with sine of u, but then there's also going to be implicit differentiation with the y's mixed in with the x's. So we go through, we take it one term at a time. So x times e to the sine of 2y, we got to use product rule. So f prime, x becomes 1, f prime g plus f times g prime. So the derivative of e to the u is e to the u times u prime. So the derivative of sine of 2y is cosine of 2y times 2 dy dx. Involves derivative, we got to do dy dx. 4x goes to 4. Natural log of y is simply 1 over y times dy dx. Okay. These two terms I'm going to put on the left side, and then everything else I can put on the right side. Okay. We're trying to solve for dy dx, so divide both sides by dy dx. Negative 4 minus e to the sine of 2x e to the sine of 2y cosine 2y minus 1 over y. We could leave this as the final answer. I just want to get rid of the complex fraction here in the denominator, so I'll multiply everything through by numerator and denominator by y to get rid of this complex fraction, this denominator in under this 1 over y. So distribute y through, I get negative 4y minus y e to the sine 2y. Distribute the y through, 2xy e to the sine 2y, and when I distribute the y through to the 1 over y, the y's cancel out, leaving me with just 1. Right, number 3, find the equation of tangent line to our function x times arc cosine of x squared to the graph at the point 0, 2 pi in the given domain 0 to pi. Okay. So if we want to find the equation of tangent line, we first need to find the derivative, and from our derivative we can plug in the x value to determine the slope. Here x is a function, arc cosine, x squared is another function. We got to go through product rule again, f prime g plus f g prime. So 1 times arc cosine x squared plus f times g prime. So with arc cosine x squared, you could set this equal to y and take the cosine of both sides, do it implicitly. But here I'm just applying the arc cosine rule, which is simply negative u over square root of 1 minus u squared. My u value is x squared, so negative 2x divided by square root of 1 minus x squared squared, which will make it 1 minus x to the fourth. Okay, so I have my derivative, plug 0 into my derivative because I want to find the slope at that point. Arc cosine is 0 plus 0 times, and everything here will just turn to 0. So arc cosine is 0, cosine is 0 at pi over 2 and 3 pi over 2. But we always have to check with our domain, right? 3 pi over 2 is outside of our domain, so only pi over 2. So our slope is pi over 2, our point is 0, 2 pi, so y minus y sub 1 equals m times x minus x sub 1, okay, point slope form. Okay, number 4, okay, find the derivative at the point 1, 0 for arc tangent of x plus y equals y squared plus pi over 4. Let's go ahead and find the equation of the tangent line as well. Okay, so we first start off by, I'm just going to go ahead and take the tangent of both sides to get the arc tangent to go away. So take the tangent of both sides. Tangent and arctangent, they are inverse functions, so they cancel out, leaving with x plus y equals tangent of y squared plus pi over 4. All right. We first need to find the derivative, and from there we can plug in 1 to get the slope, or plug in 1, 0 to get the slope. Okay, so x becomes 1, y becomes dy dx. Tangent of u becomes secant squared of u times u prime. So u prime is simply the derivative of y squared plus pi over 4. Y squared becomes 2y dy dx. Pi over 4 is a constant, so it's going to go to 0, so we'll leave that out. Okay, dy dx, just subtract 1 from both sides, so this whole mess, I can find the derivative by plugging in 1 and 0. Okay, 1 for x and 0 for y. So 0 in for y will give me secant squared of pi over 4, and y, 0 in for y will also cancel all this out to be 0. Okay, all this are being multiplied, so this all goes to 0. So 0 minus 1 is simply just negative 1. So that's my slope. So my slope is negative 1, my point is 1, 0. So my equation of tangent line is simply y minus 0 equals negative 1 times x minus 1.